Hello all and welcome back to the Ignite Hybrid Cloud series on Tanzu Mission Control for solution providers. In this module, we're going to have a look at identity and access management in TMC, which allows our operation teams to enable self-service access to an entire fleet of Kubernetes clusters for their development teams. So the first thing I want to talk about is resource hierarchy. So the organization is essentially the root level object. So all of the cluster groups and workspaces are part of an organization. So if we assign access for a group or a user at the organization level, it automatically is passed down or cascaded to cluster groups, workspaces, and clusters within that organization. But we can also assign access policies to cluster groups, which obviously are groups of clusters that we as the operation teams create to give certain teams of developers access to a subset of our fleet of Kubernetes clusters. And we can also create workspaces, which are essentially groups of namespaces from a single cluster or even a group of namespaces across multiple clusters in our environment. So we can have more granular control over how our developers access our infrastructure. So as I mentioned, policies cascade down the hierarchy tree from the organization level down through cluster groups, down to cluster and even workspaces. So policies apply to org, cluster group level, traverse multiple clusters globally. We can apply direct policy to a node in the tree. So we can apply a direct policy to a cluster or a cluster group or a workspace that will override the organization's access policy. So that's a direct policy. An inherited policy is this idea of a policy from an organization or even a cluster group cascading down to nodes within that environment. So obviously we can assign access policy to a single cluster or a cluster group, but this idea of workspaces is also interesting because the operations team can create a workspace which includes multiple namespaces across multiple clusters, even across multiple cluster groups, and assign teams access to workspaces to have more granular control over who is accessing what resources without giving a group, a developer or a team of developers access to an entire cluster. So that's pretty neat way to control how our teams access their resources via TMC. And so this is just a quick kind of workflow of what it looks like and how these identity and access policies are applied. So infrastructure teams define user access to multiple clusters or cluster groups once with role mappings. And then as new clusters are added to cluster groups or new namespaces are added to workspaces, those users that have assigned permission to those objects automatically inherit access to the new resources that are created. So we create a cluster group or a workspace once, and as the operation teams continue to populate those environments with resources, our dev teams automatically have access to those resources. I mentioned this idea of assigning roles and identity and access management to these resources. So this is a quick look at the different types of roles that are assigned. So we can actually assign cluster and namespace role bindings to users via the TMC portal. And then when users pull the kubeconfig file for their provisioned clusters or namespaces from provisioned clusters, those Kubernetes config files automatically contain either the cluster role or the role binding that has been established in TMC. So this means we don't have to manually edit and create these role bindings on the provisioned clusters. We can edit and create these roles directly in the UI or obviously the API, the TMC API, to grant access to our resources. So it gives us a single point of control for assigning these permissions to our fleet of Kubernetes clusters. And so, for instance, I can give the dev group cluster admin access to the dev group workspace while giving them cluster view or namespace view access to another workspace or another cluster group to allow them to have visibility into those clusters, but they cannot edit or deploy resources to those clusters when they pull the kubeconfig file. So we have the ability to assign those roles directly to the clusters as well as the Tanzu Mission Control portal with these Tanzu Mission Control IAM roles like workspace admin to be able to add resources to a workspace, or cluster admin to be able to add or create clusters or add clusters to a cluster group, so to speak. So that's a high-level overview of what we have, the ability we have for creating and managing access control in TMC. So let's take a quick tour of the UI to see what this looks like in practice. So welcome back to the web UI. We're going to have a look at our cluster groups first. So these are different groups of clusters I, as the operator, have set up for different clusters in the environment. So I've created an Ignite cluster group for this demonstration that has a couple of clusters, one provisioned AWS, a GKE cluster, and then a TKG or Tanzu Kubernetes Grid cluster as well. So if we click on the policy tab and the access tab within the policies page, we can start to assign access to our developer team or our unprivileged users in the environment. So if I look at my Ignite cluster group, I can see the clusters within the group, so I can assign direct access policy to the entire group or individual clusters. But I'm going to assign a role to the whole cluster group for an unprivileged user. So I'm going to select the cluster admin role, which allows kind of complete control over the environment, and give my unprivileged user access to that. So this is an identity service that's federated and a user that exists in the cloud services portal. So they'll be able to log in to TMC with that username and now have access to that cluster group. We also can assign that user to a specific workspace. So I've created an Ignite workspace that has a couple of namespaces across different clusters in my environment to give that user access to that workspace and establish a role binding of namespace view to allow them visibility into these namespaces at the cluster level. So I create this namespace view binding that allows that user to view those namespaces when accessing those clusters locally. So go ahead and add that user, and that will create the role binding on the clusters that contain those namespaces. So if we hop over to the portal logged in as our unprivileged developer or user, we can see that we have access to the 3 clusters that are provided as part of that cluster group we assigned the permissions to earlier. So I'm actually going to have a look at our Ignite AWS cluster that we created in an earlier session. Obviously, I can see, component health, extension health, information about the cluster, but I can also pull the Kubernetes config file and download that file onto my workstation to begin to deploy workloads. Since I've been given cluster admin access to this cluster group, I have kind of full control and access to this cluster via the kubeconfig file. So I've already pulled the configuration file down. I can use my kubectl commands to get information about my cluster, the nodes running in the environment. I can also have a look at the workloads or pods running in the VMware system TMC namespace, so all the agent and extension pods running. And I can also view the namespaces in the cluster, which will show 2 of the namespaces that I created via the TMC portal that are part of my workspace as well. So that's an overview into the basic workflow for granting access to users via the TMC portal. Join us in our next session when we'll have a look at applying policies to clusters, cluster groups, and workspaces in the TMC portal. Thank you.